So somebody messaged me sometime in the last half hour or so, can you still do the blindfold nunchuck thing, which is on YouTube, and it is 3 or 4 years old. So somebody's gone that far back. I haven't done it, the blindfold thing for ages, and I don't really play with the nunchucks that much anymore. But still kind of still kind of got loose. Right, there you go. One doesn't want it to be about the nunchucks, but if somebody asks, yeah, a lot of my YouTube stuff, no views. PTGR12. Everything I've been saying for years is there. Nothing's changed. Right. What we have are claims of 10 trillion. Right, I've got 3 boards here. We're going to start here. 10 trillion frames per second. Now, what does 10 trillion frames per second mean? Why am I so, this is obviously an absurdity. It starts here, 299,792 kilometers per second. This is how many kilometers light does in 1 second. So what we have from Earth to the moon, it's 186,000 kilometers on average. If we go from Earth to the moon and halfway back and another little bit, we get 279,000 kilometers. I said, sorry, that's halfway. From Earth to the moon and halfway back, it's 279,000. I worked it out to be just under a quarter of the last half, so just over 5 eighths, right? So it'd be 1, 2, 3, 4, just under 5 eighths of the way back. It's going to be an extra 20, and that will make 299,000 kilometers. That is how far light travels in 1 second. Boom, to the moon, boom, to just over halfway back. 299,792 kilometers per second, right? Now what we have here is 10 trillion frames per second. But what does it mean? We have to put things into perspective, right? So right, we've got that speed of light established, that distance, and halfway back, just over in 1 second. 10 trillion frames per second, right. 10 million, 6 zeros. 9 zeros, billion. 12 zeros, it's the trillion. This is a very, very big number, okay? A very big number. Only thing, it's probably one of the last baby things, really, when thinking about the universe, right? This figure, 9.4 trillion kilometers. That's how many is in 1 light year. There are 9.4 trillion kilometers in a light year. That's how far light goes in 1 year. This thing has still managed to operate on a bigger number, right? But condensed into 1 second, right? It's doing all of these things in 1 second. No. No, oh, not like, just like that. Surely. Darren, what are you thinking, mate? Good job you saw it. Right, so what I've done to put this absurdity into perspective, right? What I've done is stretched Earth to Moon, and just over halfway back, we've stretched it out. Daisy and Cats coming from behind, right? The line is this, from here to here, right? Stretched. 186,000 plus the other 113, which is that, gives us 299. The speed of light, it takes 1 second to go moon and halfway back. 299,792 kilometers per second. This guy, 10 trillion frames per second. I see your 299,000 and raise you another trillion, right? He's got tiny, 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 tiny sections. This is kilometers. Boom, 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 no good. So what do? We go down to meters per second. There are 1,000 meters in every kilometer. So we're going to go to meters now. So we've now got 299 million meters, right? It was 299,000 kilometers, but now because we've got meters, it's 1,000 units bigger. So now it's on 299,792,000 meters per second. The speed of light has remained the same. It's the denomination, right? The number, what we're using to, you know what I mean, centimeters, meters, kilometers, right? So we've broken it down now to meters, but still 10 trillion frames. We've got meters, we're a bit closer together, right? But we are nowhere near the 10 trillion. We're only on 299 million. So what do we do next? We're going to go from meters all the way down to millimeters, because there are 1,000 millimeters in a meter, right? So we're still though, look at this, 10 trillion frames per second. We've gone another 1,000, multiplied by another 1,000, but we're still only, look, 299,792,000,000 millimeters per second, right? So even though we've dropped, right, we're getting to smaller increments of what we can get to, and this guy's still on 10 trillion. So we've dropped from kilometers per second all the way down to the amount of millimeters per second, right? Now we're at 299 billion. We started at 299,000. So we're not going to go 1,000 now, right? So we're on millimeters, but we can't do another 1,000 because at 299 billion, all we need to do is multiply it by 10, and then we get 2 trillion. 997 billion, right? So that is where we need to get. Right? It's a long way to get there, but there's pico dollars in the way they talk about it. We don't want that. We want the units that we understand, right? Let's start giving us pico stuff. I know how it works. Let's keep it in millimeters and stuff, right? And that's what we're doing. Right, so we've gone from 299 billion meters per second, right? We multiplied it by 10. So we multiplied the 299 billion from the other page. So we were on 299 billion, 792 million, right? But it's still not small enough increments. So we're going to multiply by 10. So that means the millimeters become micrometers. It's the 10th of a millimeter. We are looking at the 10th of a millimeter, right? Boom. 2,997,200,000,000. Now we are just behind the 10 trillion frames per second, right? The speed of light has not changed. We have just changed kilometers, meters, millimeters, micrometers. We've just made bigger units so we're spread out more. Now, this is where it gets funky. So let's forget the 299 now. Let's call it 3 trillion. You know how they sometimes say it's 300,000 kilometers per second? So just to keep it simple, we're going to go for 3 trillion. All right? If you know what I mean. This isn't hard, so you might have to go back. Right? 3 trillion, 10 trillion frames per second. What these claims are, this camera, right? This camera is speechless, right? 3 trillion micrometers per second. That is the speed of light. 3 trillion micrometers every second. It's exactly the same speed as 299,792 kilometers per second. It's just broken down into the smaller ones, right? Why are we doing this? 1 centimeter, right? This is 1 centimeter. 10 millimeters, yeah? Everybody knows that. So let's grab this 1 centimeter and bring it down here. Look. So this is now 1 millimeter. All right, this is 1 millimeter. We're breaking it down again. Woof, get that? 1 centimeter, 1 millimeter, bring it down to here. This is 1 millimeter, but broken down into 10. We now take this 1 baby micrometer and put it here, right? This 10 trillion frames per second is saying that 1 micrometer, it can take individual snaps, right? 3 times in 1 micrometer. Now, that is insane. What this is saying is basically this camera, right, can be on the parallel train track or whatever is the speed of light, and it can be there with the camera going, give me a smile, speed of light. 3 times in 1 micrometer. That means about 30 times in a millimeter. This camera is doing 10 trillion shutter speed, closes and opens. 10 trillion in 1 second, right? The speed of light, we've taken it all the way down to micrometers, right? Which is 1/10 of 1 millimeter, right? That shutter speed of that camera is still going faster than those micrometers, right? So basically, when we think 1 second, don't forget, this is 1 second, right? 1 second with the camera, speed of light, go. Between here, the moon, right, and halfway back. One photograph would be 1 shutter speed. This 10 trillion has gone all the way down to micrometers, which is 1/10 of a millimeter. It's a millimeter broken down into 10 chops, right? And we take one of those chops, and in that chop, we split that 3 times, right? And that shutter speed is so fast that it can pick those 3 breakdowns, 3 sections of a micrometer. That is magic. That is not science. I don't know how that is even possible. One micrometer, 3 frames in that 1 micrometer, all right? That is 10 trillion frames per second. That's how slow it goes down. We've gone from kilometers to 299,000 kilometers per second, all the way to 2 trillion, no, 3 trillion micrometers per second. And it's still not small enough to equal their claims. Now, I hope that makes sense. I mean, I probably in the next day or two, another way of explaining this will come to me. But those are the numbers. It's ridiculous. What kind of camera does that 10 trillion times in 1 second? That piece of light that they had going in the lab, right, is basically jumping across a micrometer, a tenth of a millimeter, right? And they're timing this blue blob going blue, blue. That's not, it's just rubbish. Calling it rubbish because there is nothing that goes that fast. Like I said, speed of light here, this guy with his camera, what we saw. Smile, speed of light. Speed of light is going, huh? I'm the fastest guy, you're not, motherfucker. Smile. That is what 10 trillion frames per second looks like in the real world. Absurdities. I will find another way of explaining this. Usually just takes a day or two. Ole! I'm telling you what, absurdity after absurdity.